The next type of equations we want to look at are what we call simultaneous equations. Now, these are going to be ones where you look at it and go, well, there's an equation in x and y, but we can't solve that because there's an infinite number of values of x and y which we could put in to make 15. So like we could have x being 7, y being 1. We could have x being 3 and y being 9. So there'd be lots of different values we can put in for x and y to equal 15. And similarly, there's lots of different values we can put in for x and y here that would equal 3. But simultaneous equations is exactly what it means. Simultaneous, at the same time. So it's a case of we have two equations, and we're starting off with linear equations, so equations of lines that occur at the same time. So basically what we're seeing is where we've got two lines, and these are not the equations of these lines, this could be any two lines, but any two lines will meet at one point. And that's what we're looking to find. What's the value of x and y that makes these two exactly the same, hold the same values of x and y at exactly the same time? There's only one value here for every pair of lines. There's only one value that they will have that they will be existing at exactly the same time. So 1 point. And that's what we want to find. That's our aim, is to find the value of x and find the value of y where these two hold at the same time. Now if one's a line and another one's a parabola, then we might have 2 points. We might have 1 point. We could have no points where they exist at the same time. And we can do simultaneous equations with any different types of graphs. And you'll do them with different types of graphs as you go through. But these ones we want to do first with lines because they're the most simple ones. And there's two different ways of doing it. Now the first one we do is what we call elimination. So this is the first method we use. And elimination can only be used with equations of linear functions. So what we need to do with this one, we take our two equations and we label them 1 and 2. Now what I'm going to do here is I'm going to eliminate what the x is here. So what I want to do is multiply equation 2 by 2. So if I take everything in equation 2 and multiply it by 2, I haven't changed that equation at all. So I can do that. I can multiply 2 there, 2 there, 2 there, and it doesn't change the actual equation at all. So it'd still be the same equation, x minus y equals 3, except it just looks a little bit differently. But why I've done that is to take 2x and take the 2x here, which were equation 1 and equation 3, and do what I'm saying here. Take equation 1, subtract equation 3. So everything in equation 1 subtracts equation 3. Now, when I do that, my 2x subtracts 2x, and I get 0. So technically, I've got 0 plus the 3y here, because the 2x's will cancel. And that's the idea, is to eliminate one variable. And then I get y minus 2y, and that would give me 3y. 15 minus 6 gives us 9. Now what I've got, because I've eliminated a variable, I've got an equation with one variable now. Now we can solve equations with one variable. 3y equals 9, y is equal to 3. So if y is equal to 3, take it and put it back into any of those equations. I've put it back into 2, because 2 is the simplest one there. So when y is equal to 3, I substitute the value in there. So x minus 3 equals 3. X would be 6. So that's how we can do that. That's how we go about eliminating. Now, I eliminated the x's there. You may have said, well, wait on, can't I eliminate the y's? I could. If I say equation 1 there minus equation 2. So if I look at it that way, take these two equations, 2x minus x, well, that would give me x. Y minus y. Oh, actually, let's add the 2. We don't want to subtract them, we want to add it. So 2x plus x is 3x. And then y plus minus y gives me 0. So there's my 0 there, and I've got rid of the y. Just by adding, I can add them together. That will eliminate the y there. And then 15 plus 3 equals 18. And then 3x then would equal 18. And x is equal to 6. Which we had there. X is equal to 6. Take your x, put it in there. 6 minus y is equal to 3. So when we take that across, we get minus y equals minus 3. So y is equal to 3. There's your x, and x is equal to 6, y is equal to 3. Done two different ways, eliminating firstly the x's, and then eliminating the y's. Either way, probably you're looking at this one going, well, this was a little bit easier. Yeah, it was. I didn't have to do any manipulation, but this was showing you can do manipulation to get rid of one of the variables as well. So either way, it both worked out. Another example, 2a plus b equals 8 and 3a plus 2b equals 13. So again, we're looking here and we've set up our two equations. It's really important that we label them 1 and 2 because we do have to do some manipulation. So we're saying multiply 1 by 2, so that'll give me 4a. 2b, notice why I multiplied it by 2, because I get a 2b. I want to eliminate if I'm going to eliminate the b's, I need the same in both. So that's where I get the 2b comes from. And 2 8s are 16. So there's the manipulation we've done. Now we're saying equation 3 minus equation 2. So there's 3 and there's 2. So the 4a minus 3a gives us a. 2b minus 2b gives us the 0. 16 minus 13 gives us 3. We're straight to a equals 3. That was pretty easy. And that sometimes it works out like that. Sometimes we might have 5a is equal to something, or 2a, or minus 3a. It just depends. But this one worked out nicely. So we take a minus equals 3, substitute into 1. We could have substituted into 2, but 1 works for us, and we get b. If you do substitute into 2, you should get 6. If you don't, and this is a good way to check, if you can't substitute it into the same both equations and get the same value, there's something wrong. We've done something wrong because they're simultaneous. A being equal to 3 and b being equal to 6 should work in both equations. If it doesn't, then that's a problem. We've made an error somewhere with our numbers and we've got the wrong values, because this is where those two lines should intersect and we should get the same value. So that's a good way to check. We've talked about how we can check using equations that we are correct by substituting back in, and that does that for us. The other method is by what we call substitution. So again, we've got two simultaneous equations and we're going to use substitution this time. What this means is basically we've got our two equations, we're going to manipulate one of them. So I'll take the first one up here, p minus 7q equals 60. We'll take that and we'll add 7q off both sides. Now what I've done is put p in terms of q. So I've put one variable in terms of the other. So that's how we're going to attack this one. And then in the second equation, I'm going to substitute. So notice the p plus 2q equals minus 3 now becomes the 60 plus 7q plus 2q equals minus 3. So I've taken the first equation, manipulated it to get p equal to something in terms of q, and then substitute it. And now I've got an equation with one variable. That's what we want to do. If we can get an equation with one variable, then we're able to solve that, because we can do our brackets and get 60 plus 9q, add 60 on both sides, divide by 9, gives us q equals minus 7. So there's our value of q. We said p was equal to 60 minus 7q, substitute your minus 7 in, and p would equal 11 there. So again, take minus 7, take 11, substitute it in both those equations. If it doesn't work, then we've done something wrong. So that's our substitution method. For straight lines, you can do whichever method you like. Doesn't really matter. Like sometimes elimination will be easier, sometimes substitution. Again, the more you do, the more confident you get in saying, well, that would be better. Which one would be better? Question 2 here, however. We've got a straight line and we've got a quadratic equation. So that's a problem. We can't eliminate things here, because I can eliminate y's and try and eliminate, but then I'll have x's and x squareds and x's. So what I'm going to do is use a substitution. Y is equal to 2x minus 2, and you've got y is equal to x squared minus 3x plus 4. So y is equal to both those. So if y is equal to 2x minus 2, let's substitute that 2x minus 2 into this point here. So we get, instead of y there, we've got the 2x minus 2 equals x squared minus 3x plus 4. So what we've got then is an equation that we can manipulate, take it all on one side, and we've got a quadratic equation. Wow, we've been solving heaps of quadratic equations, and that's okay. So this gives that, when we factorise this one, x minus 2x minus 3, it's not a bad factorisation if you wanted to use the quadratic formula. then go ahead. But you'll get x is equal to 2 and x is equal to 3. You've got two solutions here. And that's okay too, because if we look at this one, we would have a parabola. So our parabola there would be intersected by a line in two places. So that generally that's what will happen. We get two solutions. You may get a situation sometimes where it only touches it in one, so you may only get one solution. That would happen. Like if you only got one value of x there, that's why. It's only just touching it. It's what we call a tangent. Or you may get a line sometimes that is all the way down here, doesn't solve it, doesn't touch it, which means it doesn't have any points of intersection. Which would mean when you do your quadratic equation, you'd try and do the quadratic formula, and then you'd get a negative under the square root. And that's be what it means. It has no solutions. There's no way that lines intersect in that parabola. And that's okay too. So once we've got our x values, we get our y values just by substituting into either one. I'd substitute back in that one, because that's the easier function. But again, 2 and 3 should substitute back into this equation to give you y is equal to 2 and y is equal to 4 when you do the substitution there. They both should hold at the same time. So we get the point 2, 2 and 3, 4 as our points of intersection. So obviously that's not drawn to scale, so don't take it as gospel for that part. But that's what it means. We've got a parabola and a straight line, and this line's cutting it twice at those 2 points. This time, equations with a straight line of mx plus b. The line contains the points 1, 8 and minus 2, 1. And they form a pair of equations, so solve it for m and b. Well, if that's the case, 1 and 8, we put in x is equal to 1, y is equal to 8, and we get m is equal to 8 minus b, and we get minus 1 for y in this case is equal to x being x is minus 2 times m plus b, which gives us this equation here. So notice I've taken this equation, 8 equals m plus b, manipulated it, and then I'm going to do the substitution because m is equal to 8 minus b, and I'm going to substitute in for that m there. So minus 2, 8 minus b plus b. I've got an equation all in b now. Now that's pretty easy to solve. You've done plenty of those. Collect your terms, do your division. B is equal to 5. So if that's the case, if b is equal to 5, m would equal 8 minus 5. So I'll just do that substitution there, and there's m. So I've manipulated that way. I had m 8 minus b. I could have done b is equal to 8 minus m. That would then done the substitution in for b. That would work out the same way. So take note of that one. And the last one here, here's another one where you've got a parabola and a line. So where are these two holding? So again, because they're both equal to y, I can make them equal. Where do these two equations hold the same time? So x is equal to x squared minus 3x. So I'd subtract x on both sides. This works out to be pretty nice. So x outside the x minus 4 when we do our factorization, which means that x must equal 0 or x is equal to 4. So there's our substitution method, taking one equation and substituting it into another. And the idea every time is to get an equation in one variable. Notice that's what we're trying to do, get an equation in one variable. Every time, an equation in one variable. Every time, an equation in one variable, all in the same variable. No matter whether we did substitution or elimination. So it's up to you. Remember, elimination will only work for straight lines. Substitution we can use for straight lines, but we have to use it for other types of curves as well. So whether we have a quadratic and a straight line, or two quadratics, or a quadratic and a cubic, or you've got log and exponential curves, doesn't matter. Trig curves as we go along, we have to do substitution to solve any other type of equation. So have a look at those. We'll have a look at questions in class, but again, you're going to be asked to do this to solve a number of problems as we go through the course. So as by itself, we won't see much, but through going through problems, you will have to find where values of x and y hold at the same time, which is simultaneously.